So thank you very much for everyone for taking the time this evening to listen to me talking about a piece of software called Terraform. And we're going to be discussing a topic called, basically referred to as infrastructure as code. And this is something that when you're using cloud platforms can really help make your lives a lot easier when it comes to managing, deploying, and working with cloud platforms. And for those of you that are on premises, there are still some options there as well, depending on what you're doing. So who am I? As Mark said, my name's John Martin, Data Platform MVP. Contact details are there. I'll make sure the slide deck and content is up online in the next couple of days, and you can get hold of it there if you want. So let's dive in. But before we go and start looking at Terraform itself, the first thing we really need to understand is the concept of infrastructure as code. What is it? Why should we be using it? What benefits can it bring? And potentially sort of what pitfalls can it give to us as well? So when we start thinking about infrastructure as code, we think about the way that we used to do management of infrastructure. We used to do deployments. We would either do it by hand, or we'd leverage capabilities in platforms like VMware, Hyper-V, or we'd use things like Chef or Puppet to help deploy that infrastructure on premises, whether it's virtual. In the physical world, it was a little bit more difficult, again, potentially doing a little bit more manually there. And what these gave us was a mechanism for actually deploying resources. But then once it was out there and it was being changed and updated and things like that, configuration changes, was all about trying to understand, okay, well, who made this change, where and when? So when you think about the way that developers work, when it comes to their code, they're checking it into source control, you've got version histories, and what that gives you is traceability. So when you start thinking about your infrastructure, the way that it looks, the way that it behaves, and the configurations that you've got there for n number of cores, or if you go to cloud resources, Azure SQL database, how are we deploying that, for example, where are we deploying it, things like that. We might make changes to those things. If we adopt some of the development ethos around treating it as code, we check it into source control, we put comments on our commits, that gives us a traceability, a history of, okay, well, what changes were made in our infrastructure when we did the latest deployment, things like that. So when it comes to troubleshooting and trying to understand what happened, we've made this change and we've seen a degradation in performance, things like that. It's not a case of having to remember something or look at some PowerShell scripts and remember the parameters you put into it, because you're committing everything in source control. You're getting potentially automation platforms to do that deployment for you. So having that increased traceability helps from deployment to troubleshooting to understanding, okay, what changes were made when by who. So change control, regulatory compliance, things like that. It makes life a lot easier. When we think about the encapsulation of complexity, now, one of the things that we've always had when we come to do infrastructure deployments is when you get someone in the mix, you get people doing things manually, for example, your consistency is not going to be the greatest, because especially if you've got very complex infrastructures where you've got tens of servers or tens of hundreds of databases or things like that, where you've got to get things repeatedly set up over and over and over, and that complexity can sometimes be a little bit much for people to take in and handle and get consistency, especially if you then start breaking that out across a team. When we start thinking about encapsulation, we can actually take all of that complexity, build it into a code module, abstract it away, and then the people doing deployment, potentially, if they're doing it interactively, can do that in such a way that all they need to do is feed in some parameters and it makes life easier. So you put something in and so an IS server pops out in Azure, you put some information in, and then an Azure SQL database pops out in Azure, things like that. So there's definitely some options there, and it makes life a little bit more complex when it comes to the initial learning and upskilling, because everyone knows how to build a server, everyone knows how to do deployment, but as soon as you start taking that, you wrap that complexity into the script, for example, then it becomes a lot simpler. So if you do a little bit more legwork up front, the end game and the payoff is much, much bigger. Coming back to what I said earlier about traceability, that goes hand in hand with versioning. Now, this is an interesting concept when we know that we've got versions of applications. So version 1 of our application, version 1.1, 1.3, version 2, so on and so forth. What we really want to do is take that concept, and in the cloud world, at the very least, we start looking at, okay, which version of my infrastructure deployment am I looking at, okay? And what that means is that you can go hand in hand, your application delivery of version 2 of your application runs on version 1.3 of your infrastructure. So you've got that combination, so you know exactly what's been deployed, what version that infrastructure's at, and which version of the application it's compatible with. So again, when it comes back to operating that platform, you can then come back and say, okay, well, is it as it should be? Is it a compatible matrix? That type of thing. You're going to make a change to the infrastructure. You can start looking at pulling the right version of application out and doing the deployment there. And then what that means is you can start looking at doing more unit testing, more integration testing, regression testing, to make sure that your deployments are going to be more successful. Another big thing here is idempotence. This is something that when I first started using Azure, quite some time ago now, the portal was great, but I couldn't easily do the same things over and over because I'm fallible, I'm a human. Then I moved to PowerShell, and that was great. But if I got halfway through a script and then it failed, I couldn't then just make a small tweak and then rerun the whole script because everything had been done before. In order to be able to do that, I had to then manually write in a lot of capability to make those scripts idempotent. And by that, I mean I can run it over and over and over, and I get exactly the same results out. I'm not changing anything if anything is not being sort of switched around, changed, that type of thing. Okay, so if I'm only changing one little piece of it, I can rerun the whole script. It will go, nope, that's as it should be, that's as it should be, so on and so forth. So taking a lot of these concepts, if we do this manually, it can be very complex. It can be very painful. I mean, when I used to do PowerShell side of things for deployments in Azure, it was really a case of having to remember the order in which I had to run commands, the order in which that I need to put everything together. What were those dependencies that I had to build up? What were the wrappers I had to write around the script that I actually want to do the deployment with in order to validate and test my inputs to make sure that did I actually need to perform the step? Okay, so all of that, when you do it manually, can seem onerous, it can seem overbearing, and it can seem quite daunting. But then when we start thinking about taking it into the cloud world, it's something that we have to do. And this is where Terraform comes in. Terraform helps us with all four of these sort of pillars of activity, because it abstracts away a lot of that complexity as well in the way that we write and define the resources. And we'll look at that towards the back end of the session. So why would we do this? First and foremost, consistency. When you start managing estates at scale, you want to make sure that you've got as much consistency as possible, because when you get called at 3 in the morning if something is broken, then you want to make sure that you're not trying to remember what obscure configuration you have on a system. I'm quite lucky at the moment. I'm only managing an estate of about 400 to 500 servers, but historically they've never been built in a consistent way. So what that means is that I'm trying to remember, okay, well, how's the storage configured here? Where is SQL Server set up? How many compute cores has this got? How much memory has this got? Things like that. And by moving across to a consistent build mechanism, it makes life a lot easier. And again, infrastructure as code helps us with that, because we can establish some patterns pretty rapidly. And when you combine that with doing some process work around t-shirt sizing, for example, your infrastructure deployments, is it a small, a medium, or a large? Or is it something bespoke? There's always going to be a case where something needs to be bespoke. There's never one size fits all or 3, 4 sizes fits all, if you see what I mean. But what it does mean is that you can consistently deploy and manage the core foundation of your infrastructure, okay? So when it comes to the cloud world, things like tags, making sure all of the right tags go into the right places with the right values. There's a couple of ways of doing it. Terraform and infrastructure as code together, and that sort of concept, that working practice, combined with potentially cloud platform policies that you're enforcing, give you a much more robust infrastructure that you build. And that makes life a lot easier for us. And the repeatability. I want to repeatably build and potentially destroy this infrastructure. So when you start thinking about the world of development and the world of operations, you bring them together, and it's a case of, okay, well, the developers are going to turn and say, well, I need a development environment, I need a test environment, I potentially need a UAT environment, potentially need a performance environment, and production as well, don't forget that. So how do you make sure that you're deploying everything correctly? Well, this is where, again, consistency. I've got one pattern for this infrastructure, so I know that I'm going to deploy dev, test, UAT, performance, and so on and so forth, all the way up to production. If I'm using the same mechanisms, I know that I'm going to get consistent deployment between every environment, which makes life a lot easier for us. having to do that over and over. So if we're doing 5 environments, historically, I do 5 builds and then right, I'm done. That's it. We've got 5. We'll leave them running all the time. That doesn't work in the cloud world. If you want to get the most out of cloud deployments, whether it's Azure, Google, Amazon, you're only running what you need when you need it, which means that I may only need that test environment for 5-6 days a month. I may need 10 of them because I've got 10 developers, and the type of model that we're using is where they're distributed and they need to be able to spin something up to do things like that. Being able to repeatably, consistently deploy all of the resources on demand and then tear them down, it gives a lot of confidence to the developers, it gives a lot of confidence to the businesses, to the end users that, yeah, we don't need it running all the time because I know that we can bring it back online at any point in time very rapidly and in a state that we know that it's going to be functioning properly. And that's where the automation piece comes in as well. So really, we want to be taking people out of the loop. People are there to deliver more high value to businesses, to organizations, to infrastructure teams, development teams. The time they spend building and deploying infrastructure is really sort of wasted time in my view. The data engineers and database and data platform and infrastructure engineers of today are highly skilled personnel, really making sure that they are interested, engaged, and looking forward to doing interesting work is the key to realizing the potential of the teams. And by moving a lot of this, I call it more mundane work of deploying and building these platforms and integrating it with the automation platforms so that you're giving developers the ability to self-serve in many cases, things like that, takes a lot of the burden off of the infrastructure teams and allow them to deliver more value to the business rapidly. It allows the database teams, for instance, to sort of concentrate on performance tuning for optimization, potentially looking at overall architectures and saying, well, let's break this out. Potentially relational's not right, things like that, the bits that add real value, the collaboration with other teams. Automation can make that all work a lot better. And we can only achieve that if we switch the mindset of doing things manually, if we switch it over to doing more of an automation infrastructure as code type of mindset. I define it, that's what I want it to look like, that's what my code will do, and that's where the infrastructure can come in. So it's really about working and collaborating well with the development teams and adopting some of that mindset, but still being a core infrastructure engineer at the very heart of it. So that's why that's why I look at infrastructure as code as something that we really need to do. And it's something that's going to give us a lot of value as we move forwards. So what are our options? Well, obviously, the title of the session gives it away. Terraform is an option, but why Terraform? So depending on which cloud platform you're using, depends on which native built-in technology you're looking at. So with Azure, you've got ARM, Azure Resource Management. You've got CloudFormation with Amazon, you've got the various different options for Google Compute, and then you've also obviously got PowerShell as well, which you can do a lot with for Azure as well. And what does this mean? Well, if you're using more than one cloud, for example, that instantly means your team has to look at using more than one technology to do infrastructure as code for deployments. That can be onerous. And again, it's one of those things, depending on how much you're using it. I know personally, if I put something down and walk away for it for a couple of weeks to focus on something else. So ARM being a great example, I'll work with ARM for a few weeks. Right, I know what I'm doing, I've got my head around this, I'll put it down, I'll go do something else for a couple of weeks, come back to it, I sit there basically going, what? Trying to remember how I did it. Because a lot of these have a high sort of element of complexity in them, the learning curve, unless you're doing it on a very regular basis all day, every day, it can become difficult to retain. And this is where Terraform really comes into it, because what it does is it gives you a platform agnostic interface to defining resources on which you want to deploy. Now, the important thing to understand here is it does not give you a platform agnostic deployment mechanism, not by a long way, because what Terraform does is it takes the HCL syntax, the definitions we define in Hashcorp configuration language, and then it interacts with the various different APIs for the cloud providers and various other systems that there are that it works with for deploying and managing resources. So what that means is obviously that the parameters you need to define and deploy a virtual machine on Azure is going to be different to an AMI image for AWS. So they're going to be two completely different definitions that will not work with one another. But what it is giving you a consistent syntax with which to define them. Okay, so we're taking that back. We're still using some of the complexity and the specific nature of those individual cloud platforms, but we're using and defining all of that in a consistent way, no matter which cloud platform we're using, whether it's Azure, whether it's Amazon, whether it's Redshift, things like, whether it's OpenShift, things like that. There's even providers potentially for VMware as well for on-premises. So if you're building hybrid environments, cloud environments, on-premises environments, and you've got those various technologies, again, you can start wrapping it all in and using a sort of consistent mechanism, a consistent language for deploying all of that. That's where Terraform is. So what is Terraform? Well, I've alluded to already. There's HCL, which is the Hashcorp configuration language. And it's a multi-platform command line tool, basically. It's open source, it's free to download, free to use. And what you do is just go to the Terraform website and download it, put it onto your platform of choice. I'm going to be demonstrating Windows later. And then what you can use is essentially you'll define the language, and then it's just call the command line tool with the appropriate parameters to basically get it to do the work we need it to do. So it doesn't matter if you're using Mac, Linux, Windows, whatever you're looking at, you've got a tool there that works for you. So where you've got the teams now that are potentially using multiple different devices, end user compute devices for managing infrastructure, again, you're coming back to having one consistent tool set over all of those platforms to allow them to function effectively. Use the Hashcorp configuration language. Now this is a sort of JSON-esque language, if you will. Lots of curly braces, key value pairs, that type of thing. And there is a bit of a learning curve to it, I'm not going to lie. Took me a couple of weeks, but after that, it became something that, because I'm used to working with PowerShell and scripting languages like that, it became relatively easy for me to put it down and then pick it up again. Because the patterns that it builds up are ones that I could easily retain. Okay, so other useful features and capabilities within Terraform is the mapping capabilities, the graphing capabilities that it has. So you remember I mentioned a little while ago, I had to remember the order in which to define my PowerShell scripts to make sure I deployed all of the resources in the appropriate orders to feed them into parameters that I can then reuse later on. So I'm going to set everything. What Terraform gives us is the ability to just define those resources in any way, shape, or form, and then potentially I can reference a parameter or property from another resource in one other, and Terraform will recognize that relationship and that dependency between those resources. What that means is I don't have to give two hoots about the way that I write my definitions, because Terraform will figure that out for me. Now I can either do that implicitly by turning around and saying, okay, I'm going to reference this other resource and I'm going to reference this particular property of it. Or I can set an explicit dependency by naming that and using a depends on property within that resource. So whether you're doing implicitly or explicitly, you've got that ability to build that up. And what that means is that Terraform can derive from that, okay, well, what are the interdependencies where it's going to serialize those deployments? So I've got to deploy obviously, if we think about using Azure, for example, I've got to deploy the resource group. And in that case, that happens. That's one thread, one activity. If I've got 5 different resource groups, then potentially I can multi-thread that and then basically deploy 5 in parallel, because there are no relationships potentially between them. Okay, once we're into that, within that resource group, I'm deploying an Azure SQL database server, VNets, and all those sorts of things. And again, if I've got the ability to say, right, these are the dependencies between these objects and these resources, Terraform will then say, okay, well, I need to do that in that order, but when it gets to there, I can actually do all of those in parallel. So it can actually help by speeding up those deployments, because it's got that parallelism built into it. It's not something that I need to do with PowerShell jobs or anything like that. And the bit that I really like about it is it's designed as a stateful mechanism. So I can get it to maintain the state. Now, as a developer, that may be on my machine so that I know what I'm doing, what my environment looks like and such like. And then potentially what we're looking at is coming up and saying, okay, well, maybe if I store this state centrally, what does that mean for me? Well, it means that if I've got a team-based development environment and we're deploying into one set of resources, then if I'm doing something with it, I can take a lock on that environment, and that means no one else can do deployment whilst I'm in the middle of moving anything. It also then gives us an environment to say, okay, this is what it should be baselined at. Has someone made a change outside of the normal protocols? So again, we end up with that ability to say, okay, well, is this as it should be? Or have we got some drift in our infrastructure configuration, things like that, which makes life a lot easier. And you can store that state file, S3 buckets, blob storage, or even Hashcorp's backend system itself. So now we're getting in there. Now we're saying, okay, well, yeah, we're going to use Terraform. What are the components that go together to actually building and defining an infrastructure that we would deploy and manage with Terraform? So in this instance, the most fundamental one here is providers. The provider essentially is the mechanism by which we define what we're going to be talking to, the types of resources that we're going to be deploying. So there is a provider for Azure, there is a provider for Google, there is a provider for Amazon, there's one for OpenShift, there is one for VMware. There are literally hundreds of providers out there. For example, even GitHub's got a provider now, so you can manage repositories and access to repositories and things like that through Terraform if you so desire. So there is an awful lot that you can do with it, and there's a lot of systems you can interact with, but those providers are the ones that allow you to have that interface so that you know that you're deploying an Azure virtual machine versus an AWS AMI. Those providers themselves, again, typically open source. What it means is that as we progress through this, there's going to be a lot of development going on, and the versions are coming out, and there's a lot of capability being uplifted all of the time. So when we define our Terraform projects, if you will, we can actually say, right, I want to use the latest version of the provider, or I want to use a specific version of the provider. And depending on what you're doing, it depends on which way you want it to go, really. So for example, if you've got an environment and you're deploying those resources on a regular basis, I would say you want to stick with one specific version of the provider. And then if you need to make a change, you can then uplift that and roll that through all of your environments, validating it against the applications that are running on it at that point in time as well. So within those providers, I've already mentioned a few times, we've got the resources, and this is where you've got your virtual machines, your Azure SQL databases, your SQL servers, your data warehouses, all of these resources that we want to deploy into our cloud environments, potentially on-premises environments if we're looking at things like VMware. And these are where we define things like the names of them, the locations of them, the configurations around disks and compute and things like that. Okay, now the important thing to understand when it comes to managing resources with Terraform is that you are managing the resource itself. You're not managing the contents of that. Okay, so Terraform is fantastic when you're dealing with platform as a service, because you're essentially then dealing with properties directly affecting the performance of it, the configuration of it. When you start dealing with virtual machines, where you've got an internal operating system, that's where it gets a little bit more complex. And Terraform is not designed to go in there and flip registry bits. It's not designed to go in there and set user rights assignment and things like that in local security policy, okay? It's purely about, what does this virtual machine look like? How is it configured from an infrastructure perspective? If you want to configure the internals, then that's where things like PowerShell DSC, Ansible, Chef, Puppet, and allying it to a different automation platform that's there to work with the contents of it. So you'll be writing PowerShell scripts that get run in order to do that work. Data sources. Now, if you've got an environment where, for example, you're building a hub and spoke architecture in Microsoft Azure, you may have other resources that are outside of your project that you're deploying. So you need to be able to reference them. You need to be able to pull values in. There's a couple of ways of doing it. One, you can reference their state files, but that may not always be the case. If you've got an existing infrastructure in place, for example, and you're transitioning to use Terraform, you may not have that. What data sources allow you to do essentially is define, I want you to go and look up in this cloud platform for this resource and give me the properties of it so that I can reference them elsewhere. So for example, hub and spoke, then you want to pull back VNet information so that you can plug the right things in, so you can set up all of the VPNs or the peering and things like that. So they can be very, very useful. Variables. Really, if you want to abstract everything where you want to encapsulate, which is the topics that I talked about earlier, you really need variables, because you don't want to be defining and hard coding properties throughout your projects, because then you basically lose the ability to reuse them. Whereas if you parameterize and then set variables, it means that you can call those things and pass in values for those variables. There's a couple of ways of doing it. You can do it at runtime, where you're doing the command line call and you can feed them in, or you can feed in a parameters file, variables file. And what that means is you can define all of the properties you need and pass those in, which is really one of the good ways to do it when you come to using, say, automation platforms like Azure DevOps. What you'll do there is you potentially store some of the sensitive things in Key Vault. You may have some other lookup properties that you feed in on a deployment, and you can use token replacement, for example, to swap out the variable file placeholders, put in the values you need at runtime, run that through your automation platform, and out it comes the other end. And you don't have to hard code any of that in. So that can make life a little bit easier for us. Outputs. These aren't output files, these are outputs to the console window. And this is where things like in Azure DevOps, you've got the ability to read the console window. So when you're running it on your build agent or whatever, you can have it capture the output. And this is where you may want to pass out things like the IP addresses or connection details for Kubernetes clusters, for virtual machines. You may want to pass out things like the DNS names for the Azure SQL databases you're deploying, stuff like that. So you've got that connectivity information. You can then use the capabilities of things like Azure DevOps to read that screen output and then use it for the parts of the pipeline. So for example, if you're automating the deployment of an application on top of an infrastructure, you deploy the infrastructure, take some of those parameters and feed that into the next level of deployment. And that's where we achieve that sort of automation and that tight coupling for our routines. And modules are essentially, this is a mechanism whereby you define everything you've seen there in the wheel, and then from there you just nest it into a folder structure and it allows you to call it. So you're essentially building your own Terraform module. So instead of calling the individual resources and defining all of them, you've done all of that work, you've put it into a reusable module, and therefore the rest of the team, for example, then just calls the module and passes the module the parameter values. And again, that's where we're encapsulating and eliminating a lot of the complexity to deploy, for example, a multi-database environment where we've got failover groups between sites in Azure. We can turn it into this is what our configuration is, we put it into a module, we just know that we feed it these values and out comes an infrastructure, which makes our life a lot easier. So you can get the junior members of the team up to speed very rapidly, doing the same work as the more experienced members of the team. And all of this slots together like a jigsaw, and it gives us that capability, and that's what's really important for us. Okay, so you don't have to use modules, you don't have to use data sources, you don't have to use variables or outputs, but essentially the key components there are providers and resources. But if you use all of the other items together, that's where you really start leveraging that power of this platform. What we'll do here is bring up VS Code. I've got some demos here that we're going to work through. First and foremost is the authentication demo. And in this instance, there's a couple of different ways you can look at doing it. Now, if you're doing it interactively, like I'm going to be doing here on my laptop, you can use the Azure CLI to establish a session between the terminal session I have here and Azure, for example, which is where I'm going to deploy my resources in this instance, which means that I can then just start running the commands. However, if I want to do some automation, that's where things like managed identity or service principals will come in. So we can deploy a service principal, for example, and we define it as a contributor on the subscription or whatever. Now, what that means is we start looking at our main file here. So this TF file here is essentially our Terraform definition file. So it doesn't have to have anything other than the sort of .tf suffix for it to be recognized by Terraform. And that's where I'm deploying or defining a resource group. Okay, I'm saying what it's called and where it's going to go. But in order to do that, I need to then have a provider. And as I said earlier, here I'm actually saying that's the version I'm going to stick with. And in this case, I'm also specifying my subscription ID. But if I'm using a service principal, for example, then this is where I set in my subscription ID and then the various different security pieces that would fit into this. So again, if you're thinking about using it from an automation perspective, you want to potentially put placeholders in here so that you pull that sensitive information in from Azure Key Vault, substitute them in, then do the initialization, which is one of the things we need to do before we can actually deploy anything. So if we do Terraform init, it helps if I go into the right one and we do Terraform init. Now essentially what this does is it initializes my folder structure here. So you can see it's now downloading the provider for Azure RM, which is the Azure provider. And if we watch over here, we should see a .terraform folder appear. If my internet connection is going to behave itself. Here we go. Okay, so that's been initialized, which now means I can look at doing a plan. Now this is where Terraform really is quite powerful. So Terraform plan, and what it will do is it will look at the TF folders within that, TF files within that directory, and then what it'll do is, okay, well, the Terraform plan is essentially a what if. Okay, so you can see that over here it's created a terraform.tf state file. So if we look inside that file, when we come down to it, once it's been deployed, it will have pretty much this content here. So I can see that essentially what I'm looking to deploy is this resource here, and these are the various different properties. And you can see certain things will be known after apply, much like the ID of the resource and any tags that are pushed in. So in order to do that, we go Terraform Apply. And then what it'll do is, again, essentially run a what if. It'll run the plan. It'll say this is what's going to happen. I'm happy then once that I've seen that that's what's going to be deployed. So I just say yes. So it will go off and it will now deploy my resource group. And if I've got more resources in there, for example, then that will do that as well. Okay. So there we go, nice and quick. That's been deployed. So if I come down to here, we'll come into demo 2. Now demo 2 is where we're going to do the centralized state management. Okay, so part of this, I'm going to come up with my Azure CLI component, and what we'll do is if I define the account I'm going to do the deployment in, we'll run that in the, not the editor, sorry, don't save that. I want to right click, run it in terminal. Okay, so I've now defined which account I'm going to run. I'm now going to go and create a resource group. Okay, so that's now created. Within that resource group, I'm now going to create a storage account. So that'll take a little moment. There we go. So we'll just give Azure a couple of minutes to do that. Here we go. So that's our storage account created. And then we'll create a container within that with which we're going to store our backend information. Now this is where we come in and define the backend. Essentially, we're going to say which resource group, what storage account name, the container name, and then the key. So this is going to be demo.terraform.tf state. Main is exactly the same as it was for demo 1, as is the providers. Okay. So what that means, if I do Terraform init, it'll initialize the backend for me. Okay. So you can see here, whereas before it was just downloading the Azure RM configuration, it's now setting up the back end for us. So once we get around to that, all set up, we go Terraform Apply. It will go and do what it needs to do, and then we'll just say yes. So you can see there it's acquiring a state lock. Because we're using a remote state, by acquiring that state lock, what it means is that no one else can then try to deploy anything over the top of this using the same state file. So if I say yes to that, what we'll have is it will go off and it will go and create those, well, create the resource group for me. There we go, nice and quickly done. So if I come into my portal, here we go, there's the demo 1 resource group, there's our hybrid, so there's our backend. And then if I click on containers, we can see our one there. And here's our state file. So if we click on that, and then I'll just click on edit. Word of advice, don't edit it, but I'm just doing this so we can see what it is. And here we can actually see the definition of our resource and our state for our infrastructure. So all of the resources that we would look to deploy would be in here. So again, you've got this, and again, it's JSON. So we can programmatically do things with it if you want to do some form of reporting and bits and pieces. Okay. So that's how we can put a sort of centralized backend in there. So let's go to demo 3. This is the use of variables. So up until now, I've hard-coded everything. So when we start coming into demo 3, how do we do this? So again, we've got the backend information defined. Here's main. Now this is where you'll see the resource definition. Now I've got two different types of declaration here. So I've got what's referred to essentially in HL as the interpolation syntax. So if I'm just doing a standard variable declaration or something like that, I can use the one below. But if I'm doing anything that involves some form of string manipulation, for example, or if I'm concatenating various different values, that's where I'd want to use potentially the interpolation syntax, which I've highlighted there. Now, what this means is I just reference those vars. I've actually broken this out now into multiple files. So I've got a variables.tf where I'm declaring and defining my variables. I've got my providers, my main, and my backend. Now, automatically, you see when I'm asking Terraform to do the init and I'll ask it to do the apply, I'm not actually specifying any files. I'm just saying do this action, and it's doing it in the context of the directory structure that we've created there. So if we look here in variables, you can see here I can set defaults, I can set descriptions, so I can get them prompted at runtime. So do Terraform init, and initialize the backend. We'll download the Azure RM provider. Here we go. So once that comes down, we'll do the Terraform Apply. So bear with me a moment. There we go. So do Terraform Apply, and what it will do is it will go off, it will read all of my HCL definition here for my resources and everything like that. And what it should do is come back and say, okay, you actually need to give me some variable values for resource group location and resource group name. So they should pop up in just a moment. He says. My internet's really not enjoying itself today. Okay, so whilst we're waiting for that one, what I'll do is I'll start talking you through some of the other areas whilst I'm waiting for that one to do what it has to do. So in demo 4, we're going to look at what's referred to as tags. So when we're doing cloud resource management, there we go. So it's asking me to put the resource group name in. Now, what we can do here, if I just cancel that, we do Terraform apply and then vars var file equals, and then dot backslash vars demo.tf vars, I think I've called it. Do that. Essentially now what we're doing is, come back to 3, in there we've got the demo.tf vars file. Essentially this is where I'm passing in the values for the variables, so I won't be prompted for them. It should automatically just add those in for me at runtime, and there we go. Didn't get prompted this time. So yes, deploy those, and off we go. So whilst waiting for that deploy, we'll jump on to have a look at demo 4. And then this is where we're going to be managing tags. Now, when we tag resources, what it means is that we can use it in the case of Azure, it would help for billing roll-up potentially. So you can attribute resources to business units, to cost centers, to things like that. What it also means is that one of the key things that Azure and a lot of cloud providers don't have is created date. And this is a bugbear of mine. There's a couple of different ways of doing it, but you can put create date, you can put last updated or last change date and that type of thing in here, because what you can do when you do with automation is you can feed a value in and update that as well as you go. And that makes life a little bit easier. So what I'll do actually is just pull this one out, save that file, or initialize it. But essentially what it means is we want to put tags into our resource group. Now, you can specify them one tag at a time, but what that means is you then have to go back to every resource and update them. What we can do here is actually use a locals variable in tags, and what we can do essentially is create a hash table, if you will, where I've got the environment, contact, cost center, usage, created date, okay? And what this means is that if I come to my resource, I can actually say merge all of those together into one piece that I will push through. So what that means, if I need to add any tags, I just come back to one place and I update that. So if I go apply var file equals /demo.vars, what we'll see here is when it goes through and it starts putting that information in, because I'm now specifying those tags as we go, I'm not specifying one for this, so we'll set the date for that one. What it will do is we'll actually be able to see that information, those values in the plan. So again, where we're actually explicitly defining things, we can actually push that information in. So yes, do that. We can see there, those are the tags, whereas we said before, we'll see what they are at deployment time. Okay. So all in all, we can start building this up. Okay, I'm just deploying a single resource group at the moment. That's really just for brevity so that it's easy for us to see what's going on, and it goes through pretty rapidly. Now, if we get through the last demo now about dependencies. Now, in this instance, what I'm going to do is I've got the backend, main, providers, tags, and variables files, but when we come to main, what we're going to look at here is I've got the resource group, I've got the Azure SQL Server, and I've got an Azure SQL database that I'm going to deploy, and then a firewall rule set, okay? So I can put a lot of this information in, and it will spit things out. So if I go init, oh, it always helps you spell Terraform correctly. So we'll initialize this one, and then what we'll do is we'll deploy that one. So, but yeah, if we look at this one here, and I'll talk you through that code now, is there's the resource group details, and there's the resource group details again. Let's try initializing that again. Okay, there we go, that's better. Starting to behave itself now. So we start coming in here, and we can do, if we want to deploy multiples, we've then got account option. So here, let's just say if I want to deploy 5 databases, which I'm then going to deploy a DAC pack to, for example, 5 DAC packs, I can deploy the databases, and I can then include the count potentially as part of the name. And you can also see here where I'm actually defining the properties of the database for resource group location and server name. I'm referencing the actual SQL Server that I'm defining above it. So what that means then is that when I do the build, it will have a look at that and it will say, right, I need to deploy the resource group, I need to deploy the Azure SQL Server, and then I can deploy all of these databases essentially in parallel, because there's no interdependency between the databases, but they do deploy on the one above. So Terraform Apply, we'll do that. Oops. it helps if I pass in the TFVARs file. So again, what we'll do here is go through 8/18, so that's our created date. Obviously, if I'm using Azure DevOps, then I don't have to sit there and type that, but I'm doing a very poor impression of Azure DevOps myself with the way I'm typing this out, but you get the idea. And you can see there that we're doing a much bigger plan, and we can see what those values are. We can see what's going to be known after apply. We can see where those resources are. So I just say yes. And then we're done, he says. So whilst I'm waiting for that to go and do what it's going to do, we'll have a quick look here at the various different bits and pieces. So you can see here when we start looking at the state files for some of the things we deployed as part of this one. If I click on edit, you can start seeing here that I've got information around tags. I can see what's going on with things. So there's demo 4, demo 5, the various different bits and pieces. So if we come back to this one. Oh, I've got a typo in there, but we've run out of time, so I'm going to skip on. I'll get that code corrected, then I'll get that issued out afterwards. But we're running up on time, being mindful of the delay we had at the start. So in summary, hopefully this has given you some ideas around infrastructure as code as a concept and using Terraform and sort of showing you some of the power that it has. Obviously, when you start doing that, where you're doing potentially multi-cloud deployments, multi-cloud management. So if you're an ISV, for example, and you want an offering in Azure, you want an offering built on Amazon, you've got that single unified plane for actually defining resources and managing those things. Allows us to really make use of things like automation, deployment pipelines, along with versioning both our applications and our infrastructure to really give us that ability to operate a platform more effectively and understand what's there, what version things are on, and give us some level of due diligence around making sure that we've got everything tested and we know that we can go back and look at those test plans, the different versions of infrastructure that we're working with. And all of that will then give us much better governance overall. So there's a lot of benefits to it. There is a learning curve, I'm not going to lie to you. As with any new technology, if you want to adopt it, you're going to have to learn it. But my personal experience is that I've found the learning curve for Terraform a lot less steep than the learning curve for things like ARM and CloudFormation to really get the most out of it. And with that, I just want to say thank you very much for your time. I really appreciate it. And have we got any questions at all, Mark or Mikhail?
Perfect. Thank you very much for that. Yeah, we've got some questions prepared for you. So I'm going to go first. So are there any ways you can use Terraform to detect differences of a resource against your code so that you know you have deviations in your environment? So I guess a good example there would be if you've got a already deployed resource and somebody's gone on there, maybe added some tags manually or something.
So you can either manually run a Terraform plan referencing the state file, and that will say the state will be basically the last thing that was deployed, so long as it's been maintained. One of the problems you do face is if people start deploying projects and they haven't got state files that potentially overwrite things, so you need to make sure that the state file is centralized. But again, if someone manipulates that infrastructure and you've got the infrastructure essentially under management, if you do a Terraform plan, then that will let you notify. Now you can do that interactively, or you can actually build that in as part of a deployment pipeline to avoid flattening any changes without first investigating them. You can actually build a plan in as part of the deployment pipeline. And if you basically use the console read capabilities, you can then say, actually, we've got things where it's going to potentially destroy outside of what we were anticipating. Stop. So there's some controls that you can build in there, but it's not fail-safe. There is the potential there that you can overwrite those changes, but there is a way of detecting them, yes.
Excellent.
Yes, the second question was, is there an option for Terraform for on-premises? But I think you answered that question in your description. It was yes, if I understood it correctly.
Yes, I mean the Terraform application itself is it's an executable I've got installed on my laptop here, or you'd have it on a build server or something like that. For managing resources, then there is a VMware provider, so you can interact with VMware and virtualization platform. There isn't one for Hyper-V, but then if you're running things like OpenShift and stuff like that on premises, for example, if you're running that as a sort of private cloud, then yeah, there's providers for those as well.
So how compatible is the markup between on-premises, Azure, AVS, or the other ones?
The syntax is the same, but the properties that you define the resources with is completely different in many cases between different cloud providers.
So you couldn't reuse them?
No, so you can't define a virtual machine in Azure or an Azure SQL database and then deploy it as an Amazon virtual machine or an RDS database, for example, because they've got different parameter sets that are required by the backend APIs. There is no translation layer.
Yep.
Cool. So how easy is it to deploy Terraform code in Azure DevOps? I know you've alluded to the fact that it is possible. So I'm talking really about release pipelines. Is it supported in classic, release, TAS, and YAML pipelines?
I believe it is. I'm trying to remember which version of the pipelines I've used when I did some work in it recently. But essentially, you've got a lot of the providers are there essentially, so there's components you can just pull in for initializing the Terraform. So obviously you check it out, you can initialize the Terraform directory. That's a standard sort of component that you can just pull off the shelf and plug in and go from that. So there's a lot of various bits and pieces there that are just off the shelf components that you can build your pipelines with.
Cool.
So how about the code changes across versions then? Because obviously there are different versions, and the older versions have issues and pains that we should avoid.
So it depends where you're
using and how compatible are they backwards.
So I mean, it depends on where you're talking about the code. So if you're talking about the core Terraform syntax, they're normally pretty good on the deprecation announcement versus actually removing it. So the interpolation syntax was actually deprecated a few versions ago, a few minor versions ago, but a few releases ago anyway, and it still works, as was demonstrated by my code today, where I've got a bit of mix of the interpolation versus the other one. There's a lot more capability coming online and fixes. Personally, I would look at upgrading the Terraform executable as frequently as possible. Obviously do your testing with that to make sure it hasn't introduced a regression or anything like that into your as you deploy it. But beyond that, you've also then got providers which are being updated. Now that's where I'd explicitly stick with a version of the provider until you're ready to do an uplift, if you see what I mean, and do an uplift on that infrastructure and do it as part of a deployment test from your route to live through your development test and so on and so forth. So in that instance, I wouldn't specify use get latest, because then you may end up with different deployments. So for example, you've got the same infrastructure deployment in 3 different places, you may end up with using 3 different versions of the provider depending on when you deploy them, and that may not be desirable.
Perfect. So if dependencies are implied and presumably will prevent parallelism of deployment, is there really any use case for defining your own dependencies?
In my experience, the times when you're using something like, say, a null provider to execute a piece of code that's not native to Terraform. So for example, if you use the null provider to execute a bash script or some PowerShell, you may want to end up and say, actually, I want to set an explicit dependency between this null provider, and it needs to run after a potentially virtual machine deployment. I need to run this piece of PowerShell to do something to the virtual machine. So you'd set an explicit dependency between the null provider instance resource or null provider resource you're creating, and then obviously if that's then sit in the middle of a pipeline and you've got a bunch of other things that then need to happen after you've run that piece of code, what you do is create an explicit dependency between the virtual machine resource being deployed effectively and then the null provider, and then the resources that depend on the null provider completing before progressing again. So that's one of the use cases that I've used for explicit dependencies.
So if I understand that correctly, the null provider is almost like you're running non-Terraform code, then, is it?
Yes, it is. Essentially, you can run external code like Bash, PowerShell, or whatever you want. So you could potentially run a piece of Bash shell script, and then run a wait for to make sure things have happened, and then your system carries on.
Perfect.
So I have an environment that is already half done. Can I somehow generate the Terraform script from this environment and not have to do a fresh start?
Not natively within Terraform, but there are some third-party modules and third-party pieces of code out there that will allow you to sort of generate them. I've not used them, so I can't comment on how effective they are.
That was my next question, but thanks.
That's all right.
How do you write Terraform for Azure resource configurations that aren't yet supported?
You don't. You essentially dovetail the Terraform deployment with the ARM deployment. So you define an ARM template. So for something like, say, managed instance, you'd leverage an ARM template and potentially deploy it through a null provider with the PowerShell commandlets or something like that. It's not the cleanest because obviously that is unmanaged code within your environment. So it does make it a little bit more difficult.
And then something to avoid as well is usernames, passwords in your Terraform files. So how easy is it to integrate Key Vault into the Terraform scripts?
So you wouldn't integrate it into the Terraform script itself. What you'd do is you'd use the deployment pipeline capabilities, something like Azure DevOps or such like to integrate with your secret management system. So you'd put the secrets into Key Vault, and then you would leverage the capabilities within the pipeline to retrieve those, substitute them in using something like token replacement, so that they get put in at runtime and injected. And not
so we use tokens or variable placeholders instead. Yeah.
Yes. If you want a more sort of integrated approach, then Terraform Vault, but that is a paid-for offering from Hashcorp. I've not used it, so I can't comment on its effectiveness and how easy it is to use.
Cool. Another question I think you've kind of alluded to. So is it possible to use conditional logic in Terraform so that you could check if something existed and take actions based upon the output?
I don't know, because I've not actually tried that. Off the top of my head, you'd probably have to do that in a deployment pipeline rather than the native Terraform itself. I think is probably the way that I would look to do it through an automation routine. I wouldn't be able to build that logic in my experience natively into the Terraform side of things, although they have done some new releases, so I'd need to go and double check that. Sorry, I can't give you a better answer.
Yeah, no problems.
Could you just quickly show an example of a visualization map in this tool?
Yeah.
And this would be the visualization map of the SQL or the latest installation you did with the resource group and some resource inside.
Yep. So let's see if I can. There we go. So if you do Terraform Graph, what that will do is give you the dot notation digraph. So if I just copy this, do that. I don't think I've got the plugin for Terra. There is a Graph Viz plugin for VS Code, but essentially, if I come to here, plumb that in, and then I've got a graph there of how everything hangs together.
That's pretty awesome.
Yeah, it's good. I mean, like I say, there is a Graph Viz plugin for VS Code, which I'd recommend people get hold of. But again, you just get that digraph information out using the Terraform graph, and we can actually have a look at it. Can help you build or write cleaner code by looking at the dependencies and such like between them.
In order to use Terraform CLI, do I need a broker token to connect, or do I just log into the subscription somehow?
It depends what you're doing. So if you're doing, I mean, typically when I'm doing my personal development, I will use the Azure CLI interactive logon capabilities. If I'm doing automation, then I'll use a service principal, which means that essentially I'm setting up and providing the provider with things, the token information around the application name, the secret, and the subscription details. So it depends on what you're doing. But essentially, if you want to use the automation routines, that's where I'd look to inject in details around using service principals. I haven't tried it with managed identity, even though it is a possibility.
Cool. Thanks. And then we have come to the last question, unless some of you enter another quickly before we close the query store. How do I handle unique resource names between environments or deployments? Probably DNS names, storage names that need to be unique per deployment.
So again, this is where I'd use the power of the Azure DevOps pipelines to actually generate that and feed that in. So I would generate potentially some GUIDs, depending on what you're looking for. You could use a hex value or something, depending on what the resource is that you're looking to name, because you've got obviously some constraints around the format and the potential values in some of the Azure resources and the way that it's formatted. But essentially, I would generate some uniqueifiers outside of that, because then I'd look to try and store that information.
So what you're saying is pretty much that Terraform is the tool for making the exact same thing multiple times. And if you need to do different things, you need to do that, or you should do that outside of Terraform, because that's not what it's for.
Yeah, I mean, Terraform builds what you tell it to build, deploys what you tell it to deploy. So if you need anything with specific names and such like, if you need something that's globally unique, there's a couple of different ways you want to look at it. It depends on what your naming conventions are and things like that. So the way I've always done it is I've generated unique properties outside of the Terraform code itself, and then injected that at deployment runtime.
So just to sort of drill a little bit deeper into the injecting, so in an ARM template, for instance, you've got the parameters and variables. So I seem to recall you talking about the variables usage within Terraform. So it's exactly the same thing, is it? You'd be just passing that in.
Much the same. I mean, what I would do is look at, I mean, there's a couple of things you can do. Is you can either use things like defaults, and I would set up, this is one option, equals, for example, this. And then I can look at that token, or leave them as is and put it into this type of thing. And then that's where I would say, and then what I'd do is use the token replacement functionality within Azure DevOps pipelines to say, go find this, replace it with this.
Perfect.
If that makes sense.
Yeah.
I mean, you could, in theory, tokenize all of your Terraform properties as well. So if you really wanted to, you could come into here and actually tokenize this. So that would be DB name, things like that. So you can tokenize at any point, and that's where you can use the token replacement capabilities within Azure DevOps to do stuff.
Great stuff. All right, perfect. Well, I think that concludes the questions, Mikhail, doesn't it? I think we're only left to say thank you very much, John, for giving that presentation. I learned a ton of stuff, so I really appreciate
you very much for having me. I really appreciate it. Well, take care, everyone. Thank you very much. Stay safe and well. And if you've got any queries or questions, feel free to get in touch.